All right, Math 30s, this is lesson 2 from the probability unit. So it's called odds and probability. So the first question here says, a student is asked to roll a standard die, so that's a regular die. Let D be the set of all possible outcomes. So we'll sometimes call that the sample space. So this is all the things that could happen if they rolled the die. So they could roll a 1, or a 2, or a 3, or a 4, or a 5, or a 6. So event D, again, is all possible outcomes that could occur. And as we talked about last time, it's looking at, or we're talking about that all events are equally probable, meaning equally as likely. So determine the probability that a student receives a roll of 3 on the die. So we're calling our favorable outcome in this case the 3s. Oh, what am I doing? Probability of rolling a 3. So there's one way to roll a 3, and there are 6 possible outcomes. So 1 out of 6. Determine the probability that the student does not receive a 3 on the die. So now, for question C, it's probability of not a 3. So sometimes the way that you'll see that is 3 with a bar over it, or probability of not a 3 if you want to write it that way instead. So 3 with a bar over it means not 3, anything but 3. So probability of not a 3, so there's 5 ways to roll not a 3. And there are 6 possible outcomes. So there's only one way to roll a 3, so that means everything else is not a 3. And so now it says, remember from last class that probability is expressed as a ratio, which we ended up doing as a fraction. So the probability of event A, whatever event A is the number of desired, I don't like this slash because I don't want you to think it's dividing there, desired or favorable outcomes, whatever our event is, divided by the total number of outcomes. Odds, however, it's a related thing, but it's not the same as probability. So when we're talking about probability and odds, they're related, but they're different, and you need to keep this clear. Whoa, that was a bad star. Star. So odds are related, but a different way of representing the likelihood of an event occurring. Odds are also expressed as a ratio in fraction form, but usually I do it as a ratio, so using a colon in between. So the odds in favor of an event, so we're calling it event A, occurring are written as, so the odds in favor of A are the number of outcomes for A, whatever event A is, and then you put a colon, and then that's the number of outcomes against A, or not A. And so if you do it as a, again, let's just kind of ignore writing it as a fraction. Let's say fractions for probabilities. So we'll just kind of cross this out because I always do odds as a ratio using a colon. So this is the big part. It says, notice that total outcomes is not included in odds. And so this is a little bit hard to kind of understand written like this, but in probability, it was favorable outcomes divided by total number of outcomes. For odds, we're just looking outcomes for the event versus outcomes against the event. So up above, again, it said determine the probability that, so this is for question B up above, that the student receives a roll of 3 on the die. Now this is question D is saying determine the odds. So this is different. Question B above, because question B was the probability. So determine the odds that a student receives a roll of 3 on the, receives a 3 on the roll. So there's one way to roll a 3. So this is the odds of rolling a 3. So there's one way to roll a 3. There's 5 ways to not roll a 3. So our odds are 1 to 5. So this is my for event A. So this is rolling a 3, and this is against event A. So you see that 6 is these two numbers added together. So 1 and 5 added together is our total number of possible outcomes, but it doesn't actually make play when we're asking an odds question to use your total number of outcomes. So determine the odds that a student does not receive a 3 on the roll. So again, odds not rolling a 3. So there are 5 ways to not roll a 3. There is one way to roll a 3, so our odds would be 5 to 1. So the odds that they will not receive a roll of 3 is 5 to 1. So again, odds and probability are related but different. So you've got to think about, do I need to use my total number of outcomes, or is it just favorable versus unfavorable outcomes? So we'll go through a couple of questions here. So in a children's card game, one player holds all of the hearts of a standard deck and the other player must choose one of the cards. Determine the odds in favor of choosing a face card. So I've mentioned this before, that you need to have an understanding of what a basic deck of cards would look like. So holds all of the hearts, so the suit hearts. So there are 13 hearts in a deck. So one suit of hearts, there are 4 suits, so 52 divided by 4 is 13. Determine the odds in favor of choosing a face card. So face cards, again, those are the cards that have faces on them. So a jack, a queen, or a king. So there are 3 face cards. So write out all possible outcomes. Let H be the set of all hearts in the deck. So we could have the ace of hearts, or we could have the 2 of hearts, or we could have the 3 of hearts. What am I doing? So again, H is the set of all hearts in the deck, because again, it's saying one player holds all the hearts of a standard deck. So they've got this hand of 13 cards, it's all the hearts. So write out all of the favorable outcomes. So our favorable outcomes, based on in favor of choosing a face card. So the Jack of Hearts is a favorable outcome, the Queen of Hearts is a favorable outcome, and the King of Hearts is a favorable outcome. So I'm just going to call that F for now. Unfavorable outcomes. I guess F for face cards probably makes more sense. So not face cards is everything else. So that's the Ace of Hearts. So again, there were 3 favorable outcomes. And there are, if you count them up, 10 unfavorable outcomes. So determine the odds of choosing a face card. So again, when we're talking about odds, it's talking about favorable to unfavorable. So our favorable outcomes, there are 3. Our unfavorable outcomes, it is 10 unfavorable outcomes. And so now the next question says, determine the probability of choosing a face card. So this was an odds question. This is a probability question. So when we're doing probability, it's whatever our favorable outcome divided by the total number of outcomes. So our favorable outcomes are 3 favorable outcomes. Our total number of outcomes is 13. So you have a 3 in 13 probability of choosing a face card. So again, probability versus odds. You're communicating the same type of information, just in a different way. Oops, cut off part of it. So it says Gordy has 5 coins in his pocket. 3 of these coins are quarters. He reaches into his pocket and pulls out 1 coin at random. Determine the probability that the coin is a quarter. So again, I'm seeing a probability question, meaning I need to be talking about my total number of outcomes. So the probability that the coin is a quarter, sorry, that's Q if you can't read that. So there are 3 quarters and 5 coins in total. So our probability is 3 and 5. Again, you can also write things as a decimal if you want. Don't write it as a percentage though, please. Determine the odds that the coin is a quarter. So again, odds, we're talking about favorable outcomes. So drawing a quarter is our favorable outcomes to our unfavorable outcomes. So there are 2 coins that are not quarters. So 3 to 2 is our odds that the coin is a quarter. And then the next one is the coin is not a quarter. So you kind of have to think in the reverse process, but not a quarter. So there are 2 coins that are not a quarter. So that's considered our favorable outcome. Sorry, I had to sneeze there. Didn't want to scare y'all. So determine the odds that the coin is not a quarter. Oh, I think I'm going to do it again. So 2 coins are not a quarter. 3 coins are a quarter. So that would be 2 to 3. So a recent study, sounds made up, showed that the probability of obtaining a university degree is 1 in 5. So this is giving us a probability. So obtaining degree, and this is total outcomes. So determine the odds in favor of obtaining a degree. So we need to convert from probability to odds here. So again, this was our total outcomes. 5 was our total outcomes. So if we've said 1 in 5 people obtain a degree, that means 4 in 5 people do not obtain a degree. So for our odds in favor of obtaining a degree, that would be 1 obtains a degree to 4 do not obtain a degree. Determine the odds against obtaining a degree. So again, that's kind of the reverse process. That would be 4 to 1. So Pepsi runs a campaign where randomly selected bottles have a win-free bottle inside the bottle cap. I don't know if they still do this. I remember this growing up, looking under the cap for like free things. That was awesome. So the odds against finding a winner are 57 to 43. Determine the probability that a random bottle will be a winner. So lots of different things that we need to kind of tie in here. So odds against finding a winner are 57 to 43. So that's saying 57 not winners to 43 winners. Because again, the odds against finding a winner. So these are not winners. These are winners. Determine the probability that now it's changing this to a probability question. So again, odds have whatever our favorable outcome is. So in this case, since it's against finding a winner, our favorable outcome are not winners. So when we look at finding the probability of finding a winner, again, we want to say number of winners divided by total number. So 43 winners divided by our total number would need to be those two added together, 57 plus 43, which is 43 out of 100, which you could also write as a decimal, 0.43. So sometimes you're going to be jumping between probability and odds, and you need to think about how they relate. Sorry, there's lots of questions here. I don't know if I want to do all of them. Maybe we'll just, the key will be online, so you can look at question 5 and 6. I'm just going to go to question 7 because that's kind of tying in some of the stuff that we've done already with set theory. So it says there are 28 students in Mr. Connolly's grade 12 mathematics class. The number of students in the yearbook club and the number of students on student council are shown in the Venn diagram on the right. So again, in set theory, we did a lot of this. So 28 students in grade 12 math class, that's a lot more than 4 in our class. 4? Yes, 4. So what we have represented here, so 5 to 1, we've represented 8 people that are in the yearbook club, student council, and these ones again are both yearbook club and student council. So since we've only represented 8 people, we know that there are 20 people that are not in the yearbook or the student council club. So they don't, maybe they're on sports teams or do nothing like me. So the number of students in the yearbook club and the number of students on student council are shown on the Venn diagram on the right. Determine the odds a student in the class is in the yearbook club. So again, yearbook club is what I'm going to make blue here. So there are in total 7 students in the yearbook club, 28 students in total, but when it's saying odds, that's not our total number of students. We need to figure out what our unfavorable outcomes are, and those are students that are not in the yearbook club. So this 20 plus this 1, so 7 to 21. Determine the odds that a student is in the yearbook club or on student council. So 4 questions. So I can't really erase right now, but what we want to do is we now want to include these people as well. So these people are in the yearbook club or student council, these people are, and these people are. So in total, that is 8 students are in the yearbook club or on student council. So again, that would be the union, if we think back to set theory. And there are 20 students that are not a part of that. Okay, so the or, again, back to set theory, that is the union. This one's the intersection question. It says determine the odds of students is in the yearbook club and on student council. So that is just this section. Hopefully you can see that. That's just the intersection between that. So that's both. So both on the yearbook club and on student council, there's just 2. So that would be 2, 2 in total. 20 plus 5 plus 1 is 26. Determine the odds a student is in neither the yearbook club nor on student council. So is not involved with either the yearbook club or student council. So we said there are 20 students that are, and then we need to, our unfavorable outcomes are students that are involved with either of those. So 20 to 8. And the last one, we'll just look at this one. So a restaurant offers Chinese, Thai, or Korean food. The following Venn diagram shows the types of food customers like. I'm starving right now, so I want all of these. But I also like places that specialize in just one of them. That's when they do their best work. So determine the odds that any particular customer likes only Chinese food. So one thing that you would need to do is figure out how many customers were surveyed. Again, you don't have any other information about your universal set. So if we added them all up, so 10 plus 9 plus 16 plus 8 plus 23 plus 15 plus 12, there are 93 individuals that were surveyed. So the odds that any particular customer likes only Chinese food. So the only Chinese food would be this portion, because these people like Chinese food and Korean food. And these like Chinese food and Thai food. And then these people are me that like Korean, Thai, or Chinese food. I'll eat anything. I'm a garbage can. So the odds that any particular customer likes only Chinese food, so our favorable outcome is the 16. And then we would need to add up everything that's not included there or subtract 16 from 93. So that's 16 to 77. Oh, I was like, I don't understand why question B is different. But I do. Odds, probability. So probability again is taking our favorable outcome, which is the 16 people that like Chinese food, and dividing it by our total number of outcomes, which is that 93. So we get something like 0.17, or you could leave it as 16 divided by 93. So that's the probability that a customer likes only Chinese food. So onto the summary. So odds are a different way to express the likelihood of an event occurring using a fraction. Again, I don't like the fraction. Using a ratio with the symbol colon. So odds are written as the number of favorable outcomes to the number of unfavorable outcomes. Um, the total number of outcomes can be found from an odds ratio by adding the favorable outcomes to the unfavorable outcomes. The biggest difference between probability and odds is that odds does not use the total number of outcomes in the ratio. So you've got some practice questions again. Compare your answers with my key, please, to make sure you're on the right track. This is a series that's easy to make mistakes between. So yep, give it a go.